Welcome back students to this lecture of RSE. So today's our topic is condenser. So what is condenser? So condenser is a heat exchanger which is in which de-superheating of high pressure high temperature vapor changes the phase from vapor to liquid and subcooling of condensate occurs. Means it is condenser is a device where phase change occurs at constant pressure. Okay, at the entry of the condenser, the condition of the refrigerant will be your high pressure and high temperature vapor, and after rejecting heat to the environment, the outlet of the condenser, the state of the refrigerant will be high pressure liquid refrigerant. Okay, so let's discuss what are different types of condenser. So see, types of condenser. So first type is your air cooled condenser, and second one is your water cooled condenser. So what is air cooled condenser? Uh, so in this air cooled condenser, the air is the working medium. Okay, as the name suggests, air is the working medium. The heat is removed by using either natural convection or forced convection. Okay, or forced convection circulation. So these condensers are made of steel, copper and aluminum tubing provided with fins to improve air added transfer. So next come to natural condenser. Okay, natural convection condenser. In such a condenser, air movement over the surface of condenser tubes is by natural convection, as air comes in contact in the worms condenser tubes is absorb heat from refrigerant, and thus the temperature of air increases. So warm air being lighter rises up, and in its place the cooler air from below rises to the take away the heat from the condenser. So this cycle goes on. Since the air moves very slowly by natural convection, the rate of flow of heat from the refrigerant to be aired will be small. So a relatively large surface in condenser surface is required. Okay, so this type of condenser is used in domestic refrigerants, and it requires very less maintenance. Okay, so next one is your forced air circulation condenser. Okay, so in this type of air cooled condenser, a fan or blower is employed to move the air over the condenser coil at a certain speed. Okay, so the condenser coil is of fin type. Fins in such coils are closely spaced. The space between the fins gets choked with draft. So to obtain a maximum capacity, the fins should be kept clean. Okay, so it is of two categories. So base mounted air cooled condenser, first one. So these condensers are used propeller fans and are mounted on the same base of compressor, motor receiver and other controls. The whole arrangement is called condensing unit. These are used on systems of 10 tons or less. Okay, so next one is your remote air cooled condenser. So these condensers are maybe horizontal or vertical type. They can be located either outside or inside the building and usually use propeller fans. They are used on systems above the 10 tons and up to 125 tons. So next type is your water cooled condensers. Okay, water cooled are basically three types, but you have to study only one type, that is your um, cell and tube. Cell and tube type condenser. Okay. So you correct this one. This will be cell and tube condenser. Okay. So just see the diagram. It consists of a cylindrical shape in which a number of straight tubes are arranged in parallel and held in place at ends by tubes. The condensing water circulated through the tubes. The refrigerant is continued in the cell between the tube seats. Water circulates in between the tubes and the end plates. The end plates being baffled to act as manifolds to guide water. The arrangement of end plate determines the number of passes the water make maximum through the condensers from one end to the other before leaving the condenser. So next one is your cooling tower. So the use of cooling tower is made when water cooled condensers are desired and water is expensive and scarcely. It is an enclosed tower like structure to which atmospheric air circulates to cooled large fans large quantity of warm water. So next one is your natural draft towers. Okay, so it is designed to cool water by means of air moving through water at low velocity. So these cooling towers should be located such that sufficient space is available all around tower for free movement of air. So water returning from condenser is sprayed down through the nozzles. Next one is your mechanical draft. Mechanical draft towers. In a mechanical draft tower, the draft means air movement is mechanical created by the fan. It is a vertical cell made of wood or metal. Water is distributed near the top of the cell and falls to a collecting basin. As it falls, passes through air, that is, circulates from the bottom to the top of the cell by either forced or induced draft fans. Because it passes against the flow of water, a given quantity of air picks up more heat than on equal quantity of air on natural draft equipment. So less air is needed to cool the same amount of water. Since the air is supplied by fans, the air quantity must be held to a minimum for low operating cost to prevent excessive water loss. Caused by draft baffles are usually installed by the top of the tower. Okay, so next one is your spray pond. Okay, students, so you have just look the diagram of the spray pond. Okay, so natural ponds were first used with water discharged near the shore and the intake water taken from the center as far below the surface as possible. In order to provide a great area of exposed water, spray ponds were developed. For these, nozzles are located so as to spray the discharged water into the air. Okay, then air they should break up the water into fine droplets but not into mist, which would easily drift off. Okay, so this is the basic of spray pond. And one more thing you have to know, what is heat rejection factor. So it is the ratio between heat rejected at the condenser to the refrigerating effect. So HRF will be QC by Rn, and you know what is QC? QC will be Rn plus W. So if you divide all the terms, it will be 1 plus 1 by COP. Okay, so there is a relationship between HRF and COP of the refrigerant. Okay, students, so this completes your chapter number 4.